Hi, welcome everyone. I'm Sri from TechieTalksAI. This is another extremely useful, practical video. I want all of you to watch this carefully, slowly till the end. It'll come definitely handy. So this is Solo Developer CI/CD guide to GitHub Actions and workflows. Imagine automating everything, building, testing, and deploying right from your GitHub repo. That is what GitHub Actions does. It's your personal DevOps engineer working behind the scenes 24/7. Hi, welcome to Techie Talks AI. I'm Sri from Schogini. On this channel, we showcase hands-on demos and insights into AI automation and no-code tools. We have created several make.com modules to simplify no-code automation for you. Subscribe and join us on this journey into the future of technology. In this session, I will show you how to understand, write, and practice GitHub Actions step by step, so you can build professional grade CI/CD pipelines as a solo developer. Core concepts. Let's start with the foundation. A workflow is your automation file written in YAML. Very simple syntax. A job is like a department. It runs tasks on one runner machine. Each step inside a job is a command or action. We will see the syntax. We will see everything in action. Each step inside a job is a command or action. An action is a pre-built reusable block. Think of it like a function. The runner is a virtual machine that executes everything, and the trigger defines when all this runs, like push, pull request, or tag. Understanding these 6 types makes the rest of the GitHub Actions effortless. The workflow anatomy. Here is the simplest workflow possible. So every workflow has a name, a trigger, jobs, and steps. So this is the trigger, and here we have the jobs. Below that, we have steps. Here we have job 1. I'll be going slow through this video because this is important. So under job, hello job, we have a step. We say run echo hello from GitHub Actions. So this runs within the runner. And this is the trigger. So here we have said whenever someone pushes code, that is because we are saying on push. So here we have said whenever someone pushes code, run one job named hello on Ubuntu and just print a message, because job has a runner, and here we are saying Ubuntu latest. It's that simple, and it proves GitHub can now run code automatically when you commit. What's an action exactly? Think of actions as modular building blocks. They are stored in GitHub repos and referenced like this: users : owner / repo @version. For example, actions checkout at v4 means we are using the checkout action built by the Actions organization, version 4. We will see this during our lab exercises. Please bear with me. This action clones your code into the runner so other steps can use it. Because this is a checkout action, you will use this one in almost every workflow, because a runner that gets instantiated will be empty. You need to check out the code into the runner so that you can work with it. And this action / checkout at v4 helps in cloning our repo into the runner. Let's see the common actions. There are thousands of actions on GitHub's marketplace. Some of the most popular are checkout to get your code, set up Python or set up No to install environments. Remember, all these are in the runner. Docker login action to log into your registry, and Docker build push actions to push images to the registry, and Apple Bay SSH action to deploy to your server. By combining just these, you can build end-to-end automation. Workflow triggers, that is on : we saw the syntax. The on section defines when the workflow runs. For example, push runs on every code push. Pull _ request triggers when a PR opens or merges. That is when the pull request opens or merges. You can even run on tag patterns like version tags v1.0.0 And there is also schedule trigger that lets you run or lets you set cron jobs. And workflow underscore dispatch allows manual runs. So GitHub Actions can run automatically or run on demand, your choice. Here is a real job example. We start with a runner, in this case, Ubuntu latest. So we tell what type of runner you want. We want Ubuntu runner, that is Ubuntu latest. Then we use actions to set up our environment. So first we check out our code into the runner. Here are the steps within this build job, and then set up Python environment needed for our job to run. And here we use with and Python 3.11. That is the version that we need. And then we execute the test. So that is when we run our own command. Here it is PyTest. Each job runs cleanly and independently, meaning reproducible automation every time. Secrets and environment variables. Automation means credentials, and GitHub makes that safe. We store API keys, tokens, password as secrets. They're encrypted and never exposed in the logs. You can also define environment variables globally or per job. Secrets are referenced as dollar, double curly brackets, secrets dot, and the variable name, close double curly brackets. While environment variables can be reused with $var underscore name. Always keep your workflow clean and your secrets protected. Full CI/CD workflow example. This is a real world CI/CD pipeline. When you push a version tag like v1.1.0, it triggers two jobs. One, build a Docker image and push it to the registry. It SSH into a live server and redeploy the running Docker Compose stack. All automated, no manual login. From commit to deployment, GitHub Actions handles everything. So lab 1, Hello World, GitHub Actions, Hello World demo. This is the starting point. Let's build confidence. Your first job is a simple Hello World. In your current project folder, create a directory .github. Inside that, create another folder, workflows, containing hello.yaml. And let it just echo hello, dollar, double curly bracket, github.actor. We will see what this gives. Push the file, go to the Actions tab, and you will see your first automation run successfully. You have just built your first CI job, continuous integration job. Let's see it. So here I have the current folder, and within that folder, I have .github/workflows folder, and within that, I have the hello.yaml workflow. Okay, so and that says, and that has one job, test, and runs on Ubuntu latest, and it has steps, say hello, and we are just echoing. We can say, I am Sri. Okay. Now, what do we do? What do we need to do? We need to first, so I will execute these commands. I've kept it here for handy reference. Git init. This initializes the current folder as a Git repo. So we do git add to add the current folder files into the repo. Then we do git commit, and we are giving the commit message CA : add hello workflow. Trigger for this workflow is on push and on workflow underscore dispatch. So that is, we can run this manually or on push. So let's create this repo using the gh command. So if you don't know what is GitHub command line utility, please watch the previous video where we have covered this. So I'm creating the repo on my GitHub account and also pushing this. See, pushed commit. So lab 1, hello actions. Let's see here, hello actions updated just now. If you click on it, you will see the lab 1. This is the README. And if you look at actions here, you will see that we have one action. If you click on it, you will see the executions. And if you click on this and click on say hello here, run echo hello Schogini branch, I am Sri. See here, this is the output. Okay, so just by pushing our code into our repo, this action got triggered, this workflow got triggered, and this is the output. So remember, this workflow got executed in a runner, Ubuntu runner, and it executed our command. We can also, using gh run list, in the command line itself, see the workflow execution. And if you do run view -- log, it will list the execution, and we can choose one by moving our up or down arrow and press enter, and it will fetch the output. See here, hello Shogini, tag master, I am Sri. So this ran 2 minutes 16 seconds ago. So from the command line also we can view the execution. So that is lab 1, hello world. So lab 2, checkout action. Now that you can run commands, let's interact with your code. Use action/checkout at v4. That is the action that we will use in this. This downloads your repo into the runner. That is inside the repo. That is the Ubuntu instance. We will have our code. That is inside the runner, which is an Ubuntu virtual machine. Our code will get copied. And we just run ls-la. You will see your files printed in the build logs. That is how the runner gains access to your source code. So most of the jobs, we will have this checkout action. That is how the runner gains access to your source code for testing or building. So let's see lab 2. So this is the lab 2. Let me cd into lab 2. And this is the lab 2 readme file. We do git init to initialize this folder as a repo. And we already have .github workflows checkout.yaml file in it. Okay, so here on push or workflow dispatch, this workflow gets executed, and the jobs within this workflow is explore, runs on Ubuntu, and the steps. First, it will check out using actions checkout, and then it will execute the command current folder pwd and ls-la to list the files in the current folder. It will show the readme.md and sample.txt file present in the current folder as the output in the log. We have the sample.txt, so let's execute git add and git commit. And then we will create the repo. We can also manually execute the workflow run like this, but since we have already pushed, this is our first push, we should be able to see the action results. GH run list. So see here, checkout demo, run view -- log. So here we can select using up or down arrow the job run. See here, readme.txt and sample.txt output of our ls-la and pwd. Pwd shows the current folder inside our runner. Okay, so that is lab where we executed the runner, where we executed a command inside the runner on push. If you look at lab 2 checkout, so lab 2 checkout, this is our repo. If you click on actions, you will see the action run, and click on it, and here you have the executions. Click on it. So here, first action is the checkout action, which gets the repo into the runner, and then we list the files. So here, see pwd and listing the files. So that is the 2 steps within this job. Okay, so next is lab 3, Docker build. Next, we automate Docker builds, add a simple Docker file using Nginx, then create a workflow that uses Docker build push action v6 with context full stop. This builds your Docker image automatically whenever you push. You will see all the build steps logged in GitHub Actions, as if you were running Docker locally. Lab 3, Docker build, and we already have the Docker file, and we also have the GitHub workflow here. So we have the build.yaml here. Okay, so job, Docker job, and run on Ubuntu. And the steps are first checkout, then Docker setup, build action, then build image. So it uses two actions. One is the checkout action, another is the Docker build action. Then it executes Docker build push action with context full stop, push false, and it tags the image, hello Nginx lab 3. Let's see this working. So here we have the README file. First, we will do git init, then git add full stop. We will commit this, and we will create the repo and push so that our workflow gets executed. Okay, it pushed. Let's go to our repo. Repositories to see the lab 3 checkout updated just now. And here, if you click on actions, you will see we have one action, one workflow execution. So here we have the Docker build and status, and the artifact Docker image is here. Context current directory. And if you click on this log, we will see the execution details. Building image, okay, Docker build, and then, okay, so that is automatically creating an image anytime you make any change in your repo code and push it. So it will automatically create the image. This is important for continuous integration. Another interesting one, lab 4, CI/CD on tag push. So now comes the real CI/CD magic. Tag your commit as v1.0.0, and then you push it. GitHub Actions detects the tag and builds the Docker image and pushes it to GitHub Container Registry automatically. This means that your release workflow can be triggered just by tagging. No scripts, no terminals. Let me cd into lab 4, and lab 4 has the Docker file in the current folder and a sample index.html. We will do git init to make this into a repo, and git add to stage the files, and git commit. Next, we will create the repo and push it. And if you see the workflow that we have on push with tags, then only the workflow gets executed. But we can manually execute also using workflow_dispatch. Let's look at our repo. So here we have the lab 4 repo. In actions, you will see that 0 workflow runs. It didn't run in spite of us pushing the code into this repo because we haven't tagged it. Now we are going to tag it, git tag v1.0.0. So that is the pattern that we have specified. V star dot star dot star. Okay, so let's execute git tag. And remember, we need to push the tags. Then only GitHub will get it. Okay, so let's refresh this page quickly. See here, just now this execution queued in progress. See here, in progress. Let's wait for, okay, it took 22 seconds. In the Docker build section of lab 3, we had push colon false. So this image will not get pushed to the registry because this account does not have the GitHub registry permission. That is the reason in lab 4 release to GitHub registry, we did not have push equal to false. We have push equal to true. That is why it gave the error. But this is the idea. This code works when you have GitHub Container Registry permission. Lab 5 is auto deploy via SSH. The final lab, here the real world deployment, we use Apple Bay SSH-action at V1 to connect to a remote server, pull the latest Docker image and restart it. With this, your application goes live the moment you tag a new release. This full automation from code to production, all in one workflow. So if you see the deploy.yaml workflow, this again gets executed when we tag and push, and the job involves these steps. First, we will check out, then we will log into GitHub Container Registry. We will build and push the image, and then we SSH into the SSH host specified in the GitHub secrets using the key and the SSH port. And then we will pull the image using Docker Compose pull, using this env production file, and then we will Docker Compose up with -d and remove orphans. So this workflow will not only create the new Docker image, it will push the image to the container registry, and then this will log into our production server and redeploys the application using the newly built image. So GitHub Actions mental model, let's visualize how it all fits together. A workflow is your overall plan. Each job is like a department executing tasks. Each step is a single instruction, and an action is a reusable function. A trigger decides when it runs, and runner is the machine executing your automation. Once you think this way, writing YAML becomes natural. Finally, some pro tips, a few power user tips. Always start with actions checkout at V4. It's your code loader, and workflow_dispatch for manual reruns. That'll come handy. Use needs to control the job order. For Docker, set pull_policy always to fetch the latest image. Pin all action at versions to avoid unexpected changes, and never hardcode secrets. Store them properly in GitHub secrets. Congratulations, you now understand GitHub Actions from syntax to full CI/CD. You can build, test, and deploy automatically, and even handle versioning with tags. Start small, practice the labs, and you will soon automate everything like a DevOps team of one. Because mastery isn't about doing more, it is about doing smartly with automation. Thank you for your time. See you again in another video. Bye-bye. Thanks for watching. Please like, share, and subscribe. Your support really helps. Have ideas or suggestions? Drop them in the comments. Let's build together. At Schogini, we offer expert NoCodeMake.com and Python AI automation consulting with ready-to-use modules to jumpstart your projects. Stay tuned and subscribe for more.